Welcome to Algebra 1, Semester 2, Unit 11, Section 13.7. Okay, today we're going to look at stem and leaf plots. You've probably dealt with stem and leaf before. Most students I've seen have, they just need to be refreshed. So let me just show you quickly what a stem and leaf is. The stem is however many digits it needs to be. The leaf is only one digit. So if we look at our data here, it's 2 digits. That means that our stem will be the tens place. We have single digits, so the tens place would be 0. Then we have 1. Then we have 2 from the 25. I don't see any 30s in here. I only see 40s, but we cannot skip and go to 40. We have to show that there's no 30s if there truly isn't. So that's the first thing you do. Now you just start recording them. 14 would go right here, 1, 4. 25 would be 2 tens and 5 ones. 8 would be 0 tens and 8. Just go ahead and stop the video and record yours. Make sure that you get what I get. 7, another 7. You do list them twice if they're in the data twice. 19 would be 1 10 and 9 ones. 27, 2 tens and 7 ones. 29, 2 tens, 9 ones. 18, 1 10 and 8 ones. 42, 4 tens and 2 ones. 23, and then 4 is 0 tens, 4. 22 is 2 tens and 2 ones. 14 is 1 4. 21 is 2 tens, 1. 3 is 0 3. 12 is 1 2. 19 is 1 9. And 41 is 4 1. Okay, now you have them in the chart by kind of a grouping system of all the like tens, but now you do have to build your leaf from smallest out. So how this says 4 2 1, it should be 4 1 2. The other thing that I wanted to show you is that stems sometimes start down here at the smallest stem value and go up to the largest. I've also seen them the other way, where they're the smallest value here and go down. I will accept either way, and be prepared to read them off of a stem and leaf chart either way. So now let's get these in order. 4 and 2 1 would be 4, and make these as evenly spread as you can. 1 2. Next one, the 3. We did have no 30s in this data. Do not put a 0 or it would indicate there was a 30. Next one, the 2 or the 20s. Our first one would be 1. Next one would be 2. Next one is 3. Next one is 5. Next one is 7. And next one is 9. Okay, our teens would be, first one is 12. Then we have 2 14s. Then we have a 18, a 19, and a 19. 0 tens, we have 3, 4, 7, 7, 8, 8. Okay. Okay, describe the distribution of the data on the intervals represented by the stems. So we're just looking at how is this spread out. Do you notice how most of the data is down here between the 0 tens up to the 20s? So I would just put most data below 20 or less than 20. Okay. Now I'm going to give you another stem and leaf to do. I'm just going to start you out on what this would be. Remember, it's only the last digit is the leaf. So I see 1,780s, I see 1,790s. So I would start it down here, 178, and that's an 8, so I'd put the 8. 1787, there we go. 1788 again, get that one in there. 181, well, we better build our stem up here. We would have to go 179, 180, 181. Okay, now 1816 would go right there. 1792 would be right there. Now you go ahead and build it and check with me in class, make sure that you've got it correct. Once you have it built, then make sure and put them in the order, building the leaf out. Okay, describe the distribution of the data. I'll expect you to have that filled in too. It definitely has certain areas where it's heavier than others. Okay, turn to the next page, page 6. We're going to read, interpret data off of stem and leaf plot. Now you notice this is a back-to-back stem and leaf plot. Look at your key here. It's showing you that it goes both ways. This is your tens column. This is the tens going both directions. So when you see the 2 and then it comes over to this side with a 1, that means 21. This way is easy to read. 2, 5 would be 25. But when we have back-to-back, this one's a mirror image of what it should be. So let's list the men's ages for the 2004 Olympics. We don't have any with 1. Now notice this time the stem is coming down and it's getting larger as it comes down. So we have 21 as our first value, 21 again, 23, 24, and 27. It's so important that you read your key and see how to do this. Next one, that would be 30. So that's the men's ages. The women, I think you'll have no problem reading. The first one would be 16. So we have 16, 16, 18, 18, 25, 26. And there's none in the 30s for the women. There's nothing listed there. Okay, percent of students in 24 countries report watching television for 4 or more hours each day. Okay, so this is the percent of students, and I'm going to have you list male and female. So turn off the video, go ahead and do that, and then we'll see if you have it correct when you get back. This was the correct answer for the women. We had 14, 15, 16, 16, 18, 18, 18, 19, 19, 19, 20, 20, 23, 23, 24, 25, 26, 26, 31, 32, 32, 33, 38, 41. And for the men, we have 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 25, 26, 26, 27, 27, 28, 34, 36, 36, 38, 38, 39, 40, 46, 46. Okay, now you're going to take that data and you're going to build a frequency table. That's really what stem and leaf plots were developed for, was to make frequency tables easier to make. Specifically, we're going to look at histograms. You guys get stumped sometimes when you see these, and there's no reason for it. We will split our sections here. Female will be just a blank white bar, and the male, we will go ahead and we'll shade him. Okay? Now we're going to count by twos, so 0, 2, 4, 6, 8, 10, 12. We'll split this once we do it. Let's look at our 10 to 19. So that's from this row right here. How many do we have that are male? We have 1, 2, 3. So on the male, 10 to 19, we'd come up to 3, and we would shade that in. For the female, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we would come up on the female graph, clear up to 10. Okay. Next one, this would be 20 to 29. This is how a histogram works. It connects intervals. So you never have a gap in it. You never have spaces like you do with bar graphs. In the 20s, for the female, we have 1, 2, 3, 4, 5, 6, 7, 8. So we come up to 8 for the female. Okay? For the male, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Wow, a lot of guys in their 20s watch television. Or actually, I should say a higher percentage in these countries watch television. Okay, do you predict that any other area will be higher than that? 12 different countries coming in with percentages in the 20s, 20 percentage range. It's a lot of your day. Okay. Or a lot of, I should say, a high percentage watching 4 or more hours. Not necessarily the part of their day, it's just the number of countries that have that. Okay, female 1, 2, 3, 4, 5 in the 30 range. Okay, so we have 5 countries where 30% of the female population is watching 4 or more hours of TV a day. For men, 1, 2, 3, 4, 5, 6, we've got 6 countries reporting that they've got 30 to 39% of their men are watching 4 or more hours a day. Now, look at how bad this gets. 41. So we have at least, whoops, broke my pencil. We have at least one country, and I could almost guess which one. We have one country where the women are watching, 41% of the women are watching, oops, I don't want to shade that in. 41% of the women are watching 4 hours or more of TV a day. We have 3 countries where there is almost half their men are watching at least 4 hours of TV a day. Okay, so the title on this would be the percent students. Now they didn't specify though if students is just in school under 18 or if it can be college students. Percent of students in 24 countries watching greater than or equal to 4 hours of TV per day. You always want to put a title on your graph down here. You can write, this would be our percents, and this would be number of countries. Okay, So those titles are real important so that people can read it properly. That one's kind of hard to read and interpret. That's the end of the notes today. See you tomorrow.